Repair materials. Plastic or wooden sheet 40 cm by 40 cm. The model is a wooden board with dimensions of 40 by 40 cm. A hole with a diameter of 5 mm is drilled at the center. 3 supporting pillars are mounted on the board. It separates by an angle of 120 degrees. A circular disc with a center hole. A bar magnet. A bolt and hexagonal nut. A ball bearing. 3 coils, each consisting of approximately 500 turns wood around a steel core. 3 LED lights, light-emitting diode. Fan plate, rotor plate. This is the model assembly. Secure the bolt perpendicular to the wooden base to serve as the rotational shaft of the system. Use the ball bearing and nut to connect the circular disc to the rotational shaft, ensuring that the disc can rotate smoothly about the axis. Fix the coils wood around steel cord onto the wooden base such that the coils are arranged coaxially with the circular disc. The 3 coils are positioned with a mutual angular displacement of 120 degrees. When the magnet rotates to a position directly facing each coil, the magnetic flux through the coil reaches its maximum value. Connect the 2 terminals of each LED to the 2 terminals of the corresponding cord. Rigidly mount to the bar magnet onto the circular disc so that the center of mass of the magnet coincides with the axis of rotation of the disc, ensuring rotational balance of the system. Attach the fan plate to the circular disc so that when wind is present, the plate causes the disc and the magnet to rotate about the same axis. As the magnet rotates, the LEDs blink on and off continuously due to the induced alternating electromotive force. This is the operating principle. When the magnet rotates, the magnetic flux through each coil varies with time. As a magnetic pole approaches a coil, the magnetic flux through the coil increases and reaches the maximum value. As the magnetic pole moves away from the position directly facing the coil, the magnetic flux gradually decreases. According to Faraday's law of electromagnetic induction, the time variation of magnetic flux in the coil induces an electromotive force, thereby generating an alternating current, which causes the LEDs to emit light. Because the 3 coils are arranged with an angular displacement of 120 degrees, the induced electromotive forces in the 3 coils are phase shifted by 120 degrees with respect to one another, Therefore, each coil generates an alternating electricity force. When the three coils are connected according to appropriate configuration, a three-phase alternating current is attained.